Okay, let's get started. Hello everyone and welcome to today's webinar, Cloud Data Analysis in a Self-Service World, How to Connect SAP Lumira to Amazon Redshift with the Simba JDBC driver. My name is Toph Whitmore. I'm the Vice President of Marketing here at Simba Technologies in Vancouver, British Columbia, Canada. And today I'll be joined by Angela Harvey, Director of Solution Management at SAP Analytics, and Kyle Porter, my colleague here at Simba, who's a Senior Sales Engineer. And today we're going to kind of talk about a couple of different things. Angela will start the presentation and will provide you with an overview of both Lumira and Redshift, showing off both the new cool features and capabilities. I'll provide a brief introduction to Simba, a little context as well for how we fit into the equation. And then Kyle will finish up with the demonstration, putting what we've illustrated into actual practice and show you how to connect Lumira to Redshift with the Simba JDBC driver, and more importantly, a lot of the cool stuff you can do once you've accomplished that. Some quick administration. If you have questions during the webinar today, please submit them via the questions window and go to webinar. We will try to get to all of your questions, but if we don't, I apologize in advance and we'll follow up with you individually after today's webinar. And so with that, I would like to hand it off to Angela. I'm going to go ahead and make her presenter, and we will get started. Angela, can you take over?
Great. Thanks a lot, Toph, and thanks everyone for joining. So like Toph mentioned, my name is Angela Harvey, and I'm responsible for our big data strategy as it relates to BI here at SAP. So before we talk about how Lumira can help you wrangle or tackle your big data, I wanted to step back a little bit and just talk about why big data is growing. It's definitely a buzz term a lot of us have heard of, but what we've really got is a perfect storm. So we've kind of got this explosion where more data is available than ever before. So a lot of us right now are wearing things like Apple Watches or Fitbits. There's sensors in our car. Of course, people are tweeting on events like this, and there's all this information from social media. And like Kyle will demo later, there's also the advent of all of these public record sets that bring in data that may not necessarily relate to your business, but it might. So we've seen this real explosion of data. And at the same time, it's cheaper to store the data than ever before. So it's cheaper for a few different reasons. The hardware is cheaper. Tools like Hadoop run on commodity hardware, or we see things like Redshift where it's actually open source and you don't have to shell out initially for the hardware costs. As well as a lot of the software technologies in big data are open source, so you're really just paying for the services around them. And even further to that, tools like Hadoop and NoSQL have the ability to not just handle traditional structured data, but also semi-structured and even unstructured data. So you're not having to do this costly ETL up front. So we've got kind of three different ways it's cheaper, more data than ever. And what that's really translating to is organizations being able to use data like never before. So do things like bring in public records and compare it to their sales to see, I don't know, does weather data impact umbrella sales, for example. So there's really no doubt that big data is growing. I mean, you can read the stats here. At the last Hadoop Summit, they anticipate enterprise data is growing 50 times year over year. So explosion of data. It's really great that we've got these cheaper ways to store it that are still accessible through enterprise BI tools like Lumira. You know, I love this stat from Forrester that most organizations are only using about 12% of their data. And we're making really big business decisions on 12% of our data. The analogy I like to use is imagine buying a 1,000-square-foot condo and only looking at one room of it. You'd never do it. So why are you making business decisions on such a small sample of your data? So definitely big data is growing, and we've got the decision. You can either go with it or be left behind. So with that, Redshift is a big data solution from Amazon Web Services. And the really neat thing about Redshift is it does definitely address the costing because it's a fully managed data warehouse. You can get it up and running really quickly and only pay for what you need. So the upfront costs, both in terms of cash as well as IT effort, are pretty low. The other thing is it really does translate into big data in the fact that it's totally scale out rather than scale up. Often with big data tools, it's hard to predict how much data is going to be brought in. So it's really important that we have this ability to scale out. The other nice thing is, since it is a data warehouse as a service, Amazon's doing all the tuning for you, so you can ensure all the parallel processing is totally optimized without actually having to worry about it. So it's a really great way to get started in big data, especially since a lot of people don't have things like NoSQL or Hadoop skills in-house. So if you're looking for a really quick way to bring in more data, Amazon Redshift is a great option because you don't actually need to have that skill set internally. And we'll talk about how Lumira can help with that. So, we've discussed the opportunities of big data, but it's not, unfortunately, not just opportunities. With more data comes more problems. So one great thing, though, is Simba helps us address that first problem. With the explosion of big data technologies, connecting to them really becomes a full-time job, which it is for Simba. And that's why at SAP we've partnered with them, because we don't have to worry about the big data connectivity. They do that for us so we can focus on our core talents of really how do you make sense of big data through visual representations. The other concern that Lumira helps address, and since Simba's taken the connectivity piece off of our plate, we can really talk about how to visualize big data and also the limited skill set of business users. I talked a little bit about how Redshift can help if you don't have the IT skill set to manage things like Hadoop. But most business users don't know SQL, let alone things like MapReduce. So it's really important that we have tools like Lumira that make it easy for them to access big data in a way that makes sense. So SAP Lumira, if you're not familiar, I'm just going to spend a couple moments speaking about it. Traditionally SAP has been really great at scalable enterprise BI, and that's still important, and it's still a core part of our business. But we've definitely seen this shift away from analysts wanting to create their own reports without having to rely on IT. They don't want to just be able to access the data. They want to be able to enrich it, merge it with other sources, and really tell a story that's compelling to their audience. And that's why we created SAP Lumira. So Lumira is a tool for business analysts and really power business users that allows them to acquire different data and explore it through their desktop. It's all done through a GUI, so like you'll see in Kyle's demo later, anyone that can use Excel can really excel using Lumira. So it empowers business users in 4 different ways. The first one is the ability to acquire data through different sources. And our partnership with Simba is really important here because they allow us to connect to all of these big data sources. As well, though, we do have the Prepare Room where you can merge your big data through things like Redshift and Hadoop with more traditional data sources. So if you're using business objects already, you can bring in Hadoop data and compare it to a business objects universe and really blend data from traditional and new data sources. The other cool thing about the Prepare Room isn't just this merging and blending of data, it's the ability to really get the data ready for visual consumption. So you can do things like add hierarchies within the Prepare Room. So maybe through your Hadoop database, you have things like sales down to the second. That's not normally how we talk about sales. So you can automatically extrapolate it out into time hierarchies where it would be represented in terms of days and quarters and more logical groupings of information. So you can definitely do things like hierarchies as well as calculations in the Prepare Room of Lumira. So once your data is all prepared and ready for visualization, that's what brings us to the Compose Room. And like you'll see in Kyle's demo, it's very drag and drop, really easy to create these visually stunning visualizations, which is a bit redundant, but really it does look nice. And even someone like myself who's not even remotely artistic can create pictures that look really nice. And we also have the ability to do infographics and other things. And of course, you can share it throughout your organization a variety of ways depending on which technologies you have in place. It can be as simple as exporting to PDF and emailing it, or you can use Lumira Server to share it, or HANA. We've got a lot of different options for sharing, so it really is a flexible tool. So I wanted to talk a little bit about why Lumira is important and some of the benefit it brings to business users in terms of trusting their data. I mean, it's really important to have access to the data, but I think we've all been there where we've reported a number to our boss and the number she has is different. So trusting the accuracy of your data is really important. So Lumira does this a few different ways. For end users, the ability to explore data from trusted IT sources is really important. So it integrates with your existing BW or business objects universes, so you can use those as data sources for your report. It also has the ability for you to see data lineage. So if you're opening Lumira content, you can see where the data is from and is it from a trusted source. And for IT, as much as they love tools like Lumira that really empower the business users and mean business users can answer their own questions without needing IT to always modify reports, it's important to them that they make sure that the data is correct and also that it's secure. So they do this a few different ways. We do have the ability to deploy Lumira in an existing managed environment. So we've got things like lifecycle management, administering and monitoring, and that can all be done through business objects. As well as we've got data governance. So really giving IT the ability to control who can do what and who can see what data. So that's kind of two ways, both in terms of authorization of who can see the Lumira content, as well as the ability to audit and track what's been done to include data loss prevention. So as much as it's important to empower the business user, we want to make sure we empower them with the correct data and don't give them the ability to sully the data too much. So with that, I will pass it back to Toph to give a bit more of an overview on Simba.
Thanks, Angela. Appreciate the introduction. I'm going to just provide a quick introduction to Simba and a little context relative to how we fit into this. Here at Simba, we make connectors. Choose your metaphor. We're the bridge, we're the glue, we're the plumbing, we're the on-ramp to your big data. Conceptually, we get you to your data so that you can use your BI tool of choice, like Lumira, to get to the data source that you need to pull or push data to or from. And we enable that working as that conduit. Now, we partner with SAP to provide connection, in this case to Redshift. And here's a context diagram that kind of puts that into perspective. Here, Simba's in the middle, and we provide the JDBC interface that enables you to connect from Lumira to your Redshift database. We, in effect, act as the conduit for commands sent between Lumira and Redshift. Fairly straightforward. We're the guys in the middle. So, you can do really great self-service cloud data analysis using Lumira coupled with Redshift, bridged, plumbed, glued by the Simba connector. But now I'd like to hand it over to my colleague Kyle, who can show you what it really looks like in practice. Let me make you presenter, Kyle, and take it away.
Perfect. Thank you, Toph. We'll just get this shared for you guys here. So what I'm going to show you is I'm going to pick a public data set. I'm going to load it into Lumira, and we're going to do a little bit of analysis on that data when it's loaded into Redshift. Since we have the Paris Climate Summit going on right now, I thought it'd be kind of fun to look at some climate data provided by the NOAA, or the National Oceanic and Atmospheric Administration. So they publish all of this data online. I believe they have records going back to 1903. So what I've done is I've pulled down their daily summaries for 2014, which you can see if you were to go and you can FTP it yourself. This gives us roughly a gig of data, or 66 million records. If you had a little bit more time to do some analysis, you might want to pull back all of the historical data and load it into Redshift. Just for the purposes of this demo, I've kept it to 2014. So we have some data to analyze. The next thing you probably already have, if you're on this webinar, is you have Redshift. So this is probably a familiar console to you, which is the Redshift Management Console. I'm looking at one of our clusters that we have set up, where I've already loaded the NOAA data for 2014 into. And then finally, you're going to need the driver. So the driver, as Toph mentioned, is your connector, your pipe to the data from Lumira to Redshift. So you can go to www.simba.com and go grab a free trial of the Redshift driver. So I have Lumira installed, and I've already installed the JDBC driver into Lumira itself so that we can use it. If you haven't seen Lumira before, this is the startup page, and what you want to do is go create a new document. And then we query with SQL. We'll pick our generic JDBC drivers, because that's where we've installed this to. Type in our credentials. So this information is all in the user guide with the driver. And the nice part is, normally for JDBC drivers, you have this long, complex URL. I'm lazy. So what you can do is you can go to your Redshift cluster console, and you can actually just copy the JDBC URL Amazon provides. And you can paste that guy in there. And then we can make a connection. So here we can actually explore our data. I'm going to go to our public data set. And I have a lookup table, which we'll just pull down and preview here. And it essentially goes from an element, which means what are we measuring, to an actual readable description. So T-sun is actually the daily total sunshine in minutes. So we're going to use that in our analysis. And similarly, I have my climate table with all my data in it for all my measurements of 2014. just going to limit it to 5 records, but here you can see we have a station ID. So this is where our measurement was taken, the date it was taken. Well, what are we measuring? So our element. The data value, and this data value differs by what is measured. We have some measurement flags, which describes a little bit about how the measurement was taken. We have a quality flag. So if the data has failed any quality checks, it's indicated here. And we have our source flag. So where was this read from? What kind of station? And then finally, the time. So I'm not actually, since I'm going to blend some data together, I'm actually going to use a SQL query. And we're going to take our station ID. We're going to take our date. And it's by default returned as just a string, so we're going to convert that to a date. That's the part. Then we're going to use our element description from our lookup table instead of that short code so that we can actually read it. We're going to take the actual data and then our quality flag. And so you can see we're doing an inner join between our climate table and our lookup table. And then we're going to filter it out. So I'm only interested in a few different types of the measurements here. There are a couple hundred different types of measurements, such as whether there's a tornado, whether there's thunder, whether there's it's snowing, raining, drizzle, the soil temperature, and so on. So I'm only picking out the precipitation, the snowfall, the snow depth, the average temperature, average wind, and then this weird one here is actually smoke and haze. For the purposes of the demo, I didn't want to pull back all 66 million records, so I'm just pulling back 3 million of them and doing a random sample. That's why there's this order by random and limit here. But if we just pull this query here, and we throw it into Lumira, and I'm just going to limit this to a small data set so you can see what this is going to look like. You can see we have our station ID. My date is now returned properly formatted as a date. We have a human readable description of what we're measuring, our data, and then our quality. So this takes a few minutes to pull down. Just for the purposes of the demo, I've already pulled this down, and so we'll load that up. And the nice part is, because we're using Redshift, if you have many people doing analysis and connections at once, you can simply scale it out, as Angela mentioned, to add more power to your Redshift cluster to allow more analysis to happen on your data. So if you haven't seen Lumira before, this is the area for our current visualization. This is our storyboard of all the vizzes we've built already. These are all the available visualizations. These are the measures and dimensions and kind of the attributes of the current visualization we're working on. These are our dimensions and measures. So essentially, dimensions are non-numeric data, and measures are numeric data. You might notice we don't have any measures right now. And that's because I didn't format the data correctly when I was inserting into Redshift, so we have no numeric data. But we can actually go and we can fix that up by using the prepare room that Angela was mentioning earlier. And this allows us to look at our data and to cleanse it and manipulate it a little bit to get into a format that we want. So one thing we can do is we can take our data value and we can actually just convert that to a number. So there we go. So we have our character data and we have our numeric data. And then we can take our numeric data and we can convert that to a measure from. And the other thing is that we have this quality flag. So if we click on quality flag, we'll actually get statistics on this. So we can see we have roughly almost 3 million records that are valid. And then we can see we have a number of failures. We really aren't interested in data that isn't valid, so we'll create a filter on this where we only want things that are valid, which is empty. Now we can see that we only have valid values left. You can do a lot more here. You can create new calculated measures. You can split, you can convert, you can trim, you can combine. It's all really easy, and it's all click-through in the GUI here. Right now, I'm just going to leave it as is, so we can get on to some visualization. First thing we probably want is how many values did we actually pull back that are actually valid. You can see we have almost 3 million. We lost about 1,700 due to quality checks. And the next thing is, because I said that we were doing a random sample across our 66 million records, what is the proportions of what we're measuring? we can use a simple pie chart of just a count of the elements and then their description. So you can see here that most of our measurements are precipitation. And then we have snowfall, snow depth, average temperature, average daily wind speeds. And then there's this really, really small one you probably can't really see that well. It's right down here is smoke and haze. So we have 4,800 elements out of our 3 million that we pulled back. And so you're probably wondering why I have this really, really small smoke and haze when I have so many other big ones. And that's because I actually found some interesting stuff in our data. So if we create a column chart and we pull across our data value, and then we filter it to just have our smoke and haze. And you notice this is all just GUI driven, just click, and we get the filters that we want. And then we change this by date. So what we're looking at now is the number of occurrences of smoke and haze across all of our measuring stations by date. So this looks a little bit it's a little bit noisy. So we can actually do a little bit better. Instead of just pulling the date directly, what we can do is we can create a date and time hierarchy, as Angela was mentioning earlier. So instead of just looking at the day by day, we can create a date and time hierarchy, which automatically pulls out year, quarter, month, and day for us. So we throw on the month here. We can see that there actually is a correlation between the time of the year and the amount of smoke and haze occurrences. So oddly enough, there's actually a higher number of smoke and haze in the winter months. For what I can't explain that. I would have assumed it would have been the inverse. So it's interesting to see that actually in the winter months there is more smoke and haze. Perhaps there's less precipitation, and we could do analysis further on that if we wanted to find out. Another thing we can do is we can look at the correlation of temperature to snow depth. So again, we can take our measurement, we can take our element description, and really what we want to look at here is snow depth and snow depth and temperature. And then again, we'll take out some of our time. So we'll take a day measurement. And then instead of a bar chart, we're actually going to use this special line chart for date time series since we have a date. And this doesn't look quite what we expected, but that's because we're doing a count. So we actually want to change this to be an average of what we're measuring. So what this does is now we're looking at the average snow depth and the average temperature across all of the stations for a particular date. And from here you can see there is an obvious correlation. As temperature goes up, the snow depth goes down. And you can also see that there is a little bit of a lag as the temperatures start to go up from the winter months. The snow depth peaks and then comes down. And you can also see the hottest months of the year are typically about July, and the most snowpack occurs about mid-February. And we can also see that there is a correlation between snowfall and snow depth. So again, we'll just do a filter between snowfall and snow depth. We'll change our visualization to use an area chart this time around. Again, we'll pull out our month. And again, we'll pull out the visualization, the coloring of what we're measuring. And we'll pull across the actual measurement. So this is a little bit harder to read here, but we can change that and make it easier by instead of choosing the average of the values, we'll choose the maximum. So this makes it a little bit easier. We can see that as our snowfall is increasing, our snowpack is also increasing drastically, and then similarly it declines across the winter months when we have none, and then drastically declines. So from here I have some interesting visualizations that I may want to share with people. And there you would compose a storyboard and then share it to maybe a Lumira server, or as Angela mentioned, maybe print a PDF and email that out, and continue on your analytics within the rest of your company. And that wraps up the demo, so I'm going to pass it back to Toph now.
Thanks, Kyle. And with that, we will wrap up the webinar, but first I wanted to address a couple of quick questions that folks had asked. Angela, I think this first one is for you. What data sources can Lumira connect to other than Redshift?
Oh, that's a great question, Tove. So there are a ton that we connect to out of the box, like all the usual suspects, of course, HANA, Business Objects Universes, now HANA Vora, Spark, Redshift, Hadoop through Hive or Impala, as well as relational data sources. So we've kind of got a myriad that you can Google there. But if there's a data source you'd like to connect to that's not on our out-of-the-box list, you've got a few different options. The first one is you can use our generic JDBC driver and then point to the Simba JDBCs. We also have a data access SDK. As well, we've got some pre-built data extensions on our partner extensions page in Lumira. A lot of them are built by Simba. And then keep watching this space because we've actually, you may have seen a press release we did recently with Simba that we're extending our partnership to bring in many more of the Simba big data drivers. So although you can connect to them now using the generic JDBC driver, we look forward to partnering more with Simba in 2016 to make sure those drivers are available out of the box.
Thanks, Angela. And last question, it might be for both of you. I'm not sure if this person caught the website piece, but the question is the Redshift driver embedded in Lumira, or do I get it somewhere else?
That's a good question. So if you're on version 129 or later with Lumira, it is out of the box. So we have Redshift and Spark now out of the box as of 129, thanks to our partnership with Simba.
And if you're looking for any other connectivity, you can also go to Simba's website at www.simba.com, and you can browse the rest of our connectors for opening up the connectivity to Lumira until we actually get those embedded.
And we just got one more question. Is JDBC mandatory between Lumira and Redshift?
JDBC is the preferred way of accessing data between Lumira and Redshift. That is the native connectivity mode, but I don't believe it's the only mode. Maybe you want to expand on that, Angela.
Yeah, I believe it's just JDBC that we offer through Redshift, but I could, if anyone wants to follow up with me, they can reach out to me at angela.harvey@sap.com, and we can get you more details on exactly what you're looking for. But the out-of-the-box connectivity is JDBC.
Cool. Well, thank you, Angela, and thank you, Kyle. And with that, I'd like to thank those of you who attended today. If you missed any part of this webinar, we will make the recording available on simba.com very soon as we can package it. But I would like to thank you for joining us and look forward to having another webinar with you soon. With that, let me go ahead and wrap up, and I'll thank our panelists one more time, Angela and Kyle. And have a great holiday, everyone listening.